All right, so today we are going to be doing lesson 24, and lesson 24 is all about turning a fraction or improper fraction into a mixed number. So this is something that we've kind of done before, but this is just a lesson kind of going over that idea. In order to know when to do this, you have to remember that when you have a fraction, the number on the top, say for example, the numerator has to be greater than the number on the bottom, the denominator. So when you see a fraction like this is an improper fraction, we can turn it into a mixed number. Now, a mixed number is just a whole number plus a fraction. But in order to figure out how many wholes you need, you have to look at the denominator. In this case, the denominator is 2. So I have to ask myself, how many halves make a whole? So I'm asking, how many halves is equal to 1 whole? 2 halves. 2 halves is equal to a whole. I know that. Can I take 2 halves away from 3 halves? Yes. What does that leave us with? 1 half, because 2 halves plus 1 half is 3 halves. So this is kind of like what we would call a sideways number bond is how we would actually call this. So now we're going to move on and do the lesson. So let's go to black. Say we have 7 thirds. If I have 7 thirds, I want to know how many thirds is equal to a whole. 3 thirds, right. So 3 thirds is equal to a whole. If I take away 3 thirds, how many would I have left? 4 thirds. So that means I can still take away another 3 thirds. So now I have 3 thirds plus 3 thirds, that's 6 thirds. How much would be left? 1 third. So again, we're kind of using that number bond idea here. So I can see 1 whole, 2 wholes, and a third. So I know that that would be a whole of 2 and a fraction of 1 third. 2 and 1 third is what my mixed number would be. Now, I can also just do it if I want to do skip counting. I could say 3 thirds, not plus, we'll erase that. 3 thirds, what would come next? Here we go, 6 thirds. Can I get to 9 thirds? No. So then you would just have your 1 third would be left. So you could do that. Now you could also just do a number line as well. I'm not really great at the number lines, but we'll try it out here. So I have a whole of 0, a whole of 1, a whole of 2. Now I'm going to get to thirds. So if I start at 0 and I want 3 thirds, I go 1 third, 2 thirds, 3 thirds, 4 thirds, 5 thirds, 6 thirds, 7 thirds. 7 thirds is also known as a whole of 2 plus 1 more third. So whether you're using a number bond or a number line or you're skip counting, either way, that this is something that is quite doable. So let's try another one. Let's try 13 fifths. So 13 fifths, again, ask yourself, how many fifths do I need to make a whole? 5 fifths. So you could take away 5 fifths. I could take another way, 5 fifths. So we have 5 fifths is a whole, 5 fifths is a whole, 5 fifths plus 5 fifths is 10 fifths. You're still going to have 3 fifths left over. So I know it equals a whole of 2 and 3 fifths. A whole of 2 and 3 fifths is what is equal to 13 fifths. Okay? So now I'm going to give you some to do as well. So let's try 12/5, and let's try 26. So those are the two I want you working on. 12/5, how many fifths is equal to a whole? 5/5. 26. The denominator is different. So how many 6 is equal to a whole? 6/6. So absolutely you can skip count. I can do 5/5. If I do another 5, it's 10/5. And then can I do another 5? No. So I know I have 1 whole and 2 wholes. So a whole of 2. If I'm at 10, I just need 2 more fifths. So I can see that 12/5 is equivalent to 2 and 2/5. Now, if I'm looking at 26, again, 6/6 is equal to a whole. So I can count by 6. 6/6. 6 plus 6 is 12. 12/6. 12 plus 6 is 18. 18/6. So I know that this is 1 whole, 2 wholes, 3 wholes. How many more do I need to get? So if I'm at 18, how many more do I need to get to 20? 2. So this one, you're going to have a whole of 3 because we're able to get to 3. And I know that 20 minus 18 is 2. The denominator stays the same. So 3 and 2, 6. Now, you don't necessarily have to do it the number bond way. I prefer it that way. Some people like it the number line way, and some people prefer multiplication. So we're going to go ahead and try to show you the multiplication method. So we're going to go back to the problem we had earlier, which was 7/3. If I have 7/3 and I know that 3/3 is a whole and 6/3 is 2 wholes. So knowing that particular information, that's going to help me get to the multiplication, because I can say 2 times 3/3, because remember 3/3 we already said was a whole. I'm going to want 2 of them, because yesterday we learned that that really just looks like this. 2 over 1 times 3/3, which is 6/3, which is still going to be a whole of 2. So that is how they got this 2 right here. Okay, so if we erase all that information, there we go. So we know 2 times 3/3. Knowing that particular information, and I know that this is going to equal 6/3, I know that I still need to add 1 more third to get to 7/3. Well, if I know that 6/3 is equal to 2 whole, you can get 2 and 1/3. So the multiplication way, some people totally get, some people don't, which is perfectly fine. That's why we have multiple ways. 10 over 4. So this is where a lot is going on in your head. So you have to know your multiples of 4. So you know 4 and 8 and 12 and 16 and 20. The list can go on, but we'll start small here. So I know a whole is 4/4. Can I do another whole? I can, because that would be 2. So I know I could get 2 times 4/4, because 2 times 4/4, this is equivalent to 8/4. If I'm at 10/4 and I'm taking away 8/4, how much do you have left? 2/4. So it will equal 2 and 2/4. Now this is where I'm going to need you to remember that both the 2 and the 4 for your numerator and denominator can be divided by 2, because they both have a factor of 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. So you get a half. So really your answer is 2 and a half is really what your answer is going to be. So now it's going to be your turn. So I'm going to write some down, and I'm going to ask you to do them. So we have 15 halves. I want you to write that as a mixed number. And the next one I want you to write as a mixed number is 17 thirds. So you should be working on this, thinking how many halves equal a whole? How many thirds equal a whole? Should I use multiplication? Could I use a number bond? Could I use a number line? So we need to be thinking, what one would you like to use? Again, multiple choices here. If I did the 15 over 2, or 15 halves, I can think of it like 15 divided by 2, just like I could think of it 17 divided by 3. Now, we haven't learned this one. 15 divided by 2, I know is 7 with a remainder of 1. And 17 divided by 3 is 5 with a remainder of 2. If this is the case, we can say the whole is 7, the remainder is the numerator, the denominator stays the same. Same can go over here. 5 would be your whole number, the numerator is your remainder, 2, and the denominator stays the same. So 5 and 2/3. But say we want to do it the way Mrs. Baker was talking about previous. So we erase all that stuff. There we go. I can take away 3/3, and then I get to 6/3, 9/3, 12/3, and 15/3. So this one I'm counting by 3. 3, 6, 9, 12, 15. That's 1 whole, 2 holes, 3 holes, 4 holes, 5 holes. So I know that this is going to have a whole of 5. If I had 15/3 and I subtract it from 17/3, you're going to have a remainder of, or what's left over as 2/3. So 5 and 2/3 is going to be your answer. This one I was doing skip counting. Now, on the 15 halves, I can use multiplication because I want to know what times 2 halves. Well, if I say 7 times 2 halves, I really kind of know that that means 14 halves. And if I take that 14 halves away from the 15, I'm going to get 1/2. So it's 7, because we had the 7 right here, and 1/2. All right, so let's try for just one more. Let's try for 16/5. I'm going to give you a little bit of time to work on that one, figuring out what you think most likely that is. Do I want to do take away a whole, skip count, number line, number bond? What do you want to do? I'm going to do a number bond. Take away a whole, take away a whole. So now I'm at 10. Take away a whole. Now I'm at 15 because that one equals 1. That equals 1. So you totally have a whole of 3. But 5, 10, 15, but you had 16, so that means you're going to have 1 left over. And the denominator, guess what? Stays the same. All right, so now it is going to be your turn. And for your turn, you're going to need to do the homework as well as do the exit ticket. That is located at bakerbuzz.weebly.com. No, it's not. It's in the Google Classroom. All right.